And I'm here to help you out with problem 17.123. And in this problem, it's a titration problem. I've already graphed actually what the sort of the answer is for this over a broad range of volumes of sodium hydroxide added, but we're supposed to calculate it at various points, one of them being right here at 10 mils, another one being right here at 20 mils, and a third one at 30 mils. So in order to do that, we're given this information. We got 25 mils of the analyte downstairs. It's got a concentration of 0.1 molar, and we're titrating with 0.125 molar titrant, sodium hydroxide. So usually the first, quite often the first task on this, and it is on this one, calculate how many moles of analyte we have. Well, there's an equation, our solubility equation, N equals CV, so I'm just going to use that, and I'm going to let Excel do that for me. Let's see, it's the concentration of analyte, 0.1, and multiply that by the volume of analyte, which is 25, and I get 2.5. Now then, how did I know that it's going to be a 20 mil titration? Well, I need to make sure that the number of moles of titrant that I add equals 2.5, and I know the concentration of my titrant. It's 0.125, as you see from here. So I'm just going to use the solute equation to calculate the volume of the titrant I need. That's how many moles I have divided by the concentration of the titrant, and that's 20 mils. Now, the next part here is, because it's going to be useful, the volume at the half equivalence point is obviously going to be 10 mils if the full equivalence point is 20 mils. And now, how do I get the pH at 10 mils? Well, 10 mils is the half equivalence point, and we know from the Henderson-Hasselbalch equation that the ratio of the conjugate base to the acid is 1 to 1, so the log term goes away, pH equals pKa. So really all I need to know is the pKa of acetic acid, which is, of course, minus the log of the Ka of the acetic acid, and I get 4.75. How are we doing here? The pH at 20 mils. Now, I'm not going to go through that in detail here because this is a problem just like you did last week in the computational exam, where you calculated the pH at the equivalence point. So the number I get there is 8.75. I'll just do that there. The last part is a little bit, we haven't looked at that all that much in the class, so let me step through that. What's happening here is after 20 mils, there's no more HA left for the titrant to react with. So this is just an excess amount of OH minus that we're dumping in there, and obviously that's going to raise the pH. So the real critical number here is how much excess OH minus have we added? Well, I've added 10 mils, so that's how much the volume of excess OH minus that I've added. How many moles is that? Well, you could probably calculate that. Go give that a shot. Okay, the moles of excess OH minus, I'm just going to use the solute equation again. The moles, which must be the concentration of the solvent times 10 mils, so that's going to be equal to, that was the concentration, and I'll multiply that by 10. So evidently we have added 1.25 millimoles of excess OH minus to that solution by the time we got over here at 30 mils, because we're 10 mils past the equivalence point. Now, what's the concentration of OH minus there? Well, once again, we'll use the same equation. I'll take N divided by the total volume. Of course, the total volume now must be however much we started with, plus however much we've added. So I'm going to say that must be equal to the excess moles divided by, and now let's think how many mils have we added. Well, we started off with 20 mils downstairs, sorry, 25 mils downstairs, so I'm going to say 25, and now we've added a total of 30 mils of titrant, so I think that's the concentration of OH minus. Now, once I know the concentration of the OH minus, I can get the POH and the pH if you want to give that a shot. Okay, here we go. I think I should just say that that's equal to minus log of the OH minus concentration. That should give me the POH. And the pH, of course, is just 14 minus that. 14 minus that value. And so hopefully I get a number here for the pH. It's 12.36. Okay.